Hi everyone, I'm Alice from Class 1. Today I want to talk about liquid buoyancy. There is no doubt that we can see many daily situations about liquid buoyancy. So let me show you some pictures. The reason why they don't fall down into water is liquid buoyancy. Liquid buoyancy is the force that causes objects to float. When a solid is placed in liquid, it is subject to an upward force so that objects can float instead of falling into the water. So, how can we calculate buoyancy? A physical scientist, Archimedes, came up with a method called Archimedes' principle to calculate buoyancy. This principle is F equals G. F represents buoyancy and G represents gravity of water displacement. Now I want to use mathematics methods to confirm this principle. So first, just look at these pictures. There are two forces in this picture, F1 and F2. So we can use pressure differences to calculate buoyancy. So we can get F equals F2 minus F1. Now we need to use another equation. F equals P times S equals rho times G times H times S. In this equation, F represents force. P means pressure, S means squares. And rho means density, G means gravitational acceleration, and H means height. So we can use this equation to take place F2 and F1. So we can get F equals rho times G times H2 times S2 minus rho times G times H1 times S1. As we all know, volume equals height times squares. So we can use volume to take place of height times L, so we can get F equals rho times G times V1 minus rho times G times V2. Because of gravity equals rho times G times V, so we can get F equals G1 minus G2. And finally, we can get the principle F equals G. And now we want to introduce the factors that have influence on the size of buoyancy. So I did two experiments. The first experiment is that we put an object into water. In this process, we change the volume of the object that is immersed in water. According to the experiment, I make a graph. According to the graph, we can find that when we put different volumes of immersed objects, we can get different sizes of buoyancy. We can find that one of the factors that affect the size of buoyancy is the volume of immersed objects. And if we immerse more volume of objects into same liquid, we can get larger buoyancy. So we can summarize that if we ensure the density of liquid, we can get an increasing linear function. For example, if we ensure that the density of liquid is 1 g per cube centimeters, we can get the function that fx equals 9.8x, and fx is an increasing linear function. The second experiment says that when we put same objects into different kinds of liquid in bottle C is water and liquid in bottle D is alcohol. According to the experiments, I make a graph. According to the graph, when we put the same objects into different liquids, the buoyancy of the same objects is different. So the second factor that affects buoyancy is the density of liquid. And according to the numbers of graph, we can get that if we put the same object into liquid which its density is larger, we can get larger sizes of buoyancy. So we can summarize that if we ensure the volume of immersed object, we can get an increase in linear function. So for like if we ensure that the volume of immersed object is 1 centimeters, we can get the function f(x) equals 9.8x, and f(x) is an increasing linear function. So that's all. That's my topic, liquid buoyancy. Sorry. Thank you for watching and listening.